you're an Autodesk Inventor user and you're wondering what a subscription to the Product Design and Manufacturing collection could do for you, you've come to the right place. The collection is designed to give us unlimited interoperability, with Inventor at the core, doing what Inventor does well, and additional products to augment that and work in an Inventor-centric workflow. The collection comes with tools like Autocad for 2D layouts and factory design, Navisworks for large design review, Recap for reality capture and point clouds, 3ds Max for content marketing, Fusion 360 giving Inventor users cloud rendering, subtractive manufacturing, and generative design, with Vault as our data management tool. Accessing Inventor through the collection gives you simulation, 2.5 to 5 axis CAM, sheet metal nesting, tolerance analysis, and factory design, a complete end-to-end workflow right inside of Inventor. And subscribers even get access to a full set of industry-specific tools through Autocad. Here's an example of how we can reuse some of our Autocad data inside of Inventor. In our assembly, we're going to reference in an Autocad drawing. We simply import the geometry directly into our part file. And once it's in, we can place it on a plane and start working directly with the geometry. All a user needs to do now is project the geometry that they want to use for the initial component. Once our initial sketch is complete, we can start working with the Autocad geometry as if it was native Inventor geometry. Now the importance of this is that we're working with references from Autocad. So it means that any downstream changes that we would make will be referenced directly back into Inventor using any CAD technology, and we'll see those updates in 3D. Yes, that's right, if you update your 2D Autocad drawing, your 3D Inventor will update as well. So while we finish off our design, we just need to go in and do some final tweaks. We need to put in some holes on the bottom of this component, and this is done again by referencing our Autocad drawing that we spoke about earlier. What we're going to do now is place some holes on top of the DWG references that we've projected over, and as soon as we've done that, we can use some Inventor features like a circular pattern to complete the design. So with that done, we can apply a material to our model and we can reference that inside of our assembly. Back inside of AutoCAD, as I mentioned before, if we make a change to the geometry, we save our drawing, the AnyCAD technology kicks in and any changes are brought back into the 3D model inside of Inventor. What about electrical and electromechanical workflows? Well, here's an example of Autocad Electrical. Autocad Electrical is a version of Autocad. What we can do is we can insert a wire between two connectors, and here we're going to copy a switch. Once I've placed the switch, we can look it up in a catalog and choose the specific switch we want to use in our design. Again, we can add new names, and once that's done, we can recolor the wire below, and then we can renumber all of the wires automatically, saving loads of time. My components and wires are synced to my catalog, and if I go into Inventor, I have the same electrical information available to me here. In this instance, I'm placing that same switch we created in Electrical into my 3D design inside of Inventor. When I'm ready, I can now choose to wire this up using the pin and wire information from Autocad Electrical. You'll see the wires come in automatically, and as soon as they're in, I can manually route them through the harness that we created previously, or I can choose to use an automatic route to tidy up the wires, as you'll see below. We can use this 3D geometry to do bend radius violation checks and nail board drawings as well. What about design collaboration? Autodesk has a phenomenal tool called Shared Views, which allows us to share a web viewable version of our file directly from Inventor. So in this example, we click Share View and a design view is created. These design views last 30 days unless you renew them, but they allow practically anybody with a web connected device to view your model online. Here you can see that we can turn components on and off. We can do measure commands where we look at the distance between specific components. We can do sections. We can rotate those sections, and you'll notice that the sections are nicely capped as well. Really nice tools for exploded views. We can hide specific components, but the best part of all of this is that we can do markups. So in this instance, the inventor users shared their design with someone else, the reviewer is having a look at the model, and they found a problem in their web browser. They save that comment back to the viewer, and the inventor user will actually see these updates directly inside of Inventor. So here we can see that there's a problem, and from here the inventor user could either reply or resolve the problem. If you work with geometry from other CAD vendors, you need AnyCAD. AnyCAD is baked directly into Inventor and allows you to work with third-party data as if it was native Inventor data. In this example, we're bringing in a component from SolidWorks, and we're referencing that into our Inventor model. You'll notice that the SolidWorks model only has 3 fixing points, whereas the Inventor model has 4. So what we can do here is create a shared view, and we can send this back to our buddy who uses the third-party software. In here, we ask them to change a hole pattern from 3 to 4, and down below you'll see them working in their geometry, making the changes that we've requested. Eventually, they'll get the design to 4 holes, and they'll let us know that they've made their changes by sending us an update through the design view. We just do an update to our Inventor model. Those changes come through as if it was a native Inventor component. From here, we can do our final assembly and do all of our design checks as normal. The Product Design and Manufacturing collection comes with Vault Basic out of the box. It allows us to easily organize and track project data, collaborate, search and find data quickly, capture file history, control access, auto-generate visualization files, and to see the impact of change and reuse data efficiently. So in this example, we're searching for bushing, and we're then going to search by material. This goes through all of the components in our vault and finds us a specific component. Looking at this component, we can see a Where Used tab, and we can see every assembly that it's used in. We've now found our top level assembly, and we can then look at a preview of it directly inside of the Vault window. And if we decide that this is the design we want to start using, we can see every component that it uses to put itself together. We can also copy this design. The Copy Design tool inside of Vault understands all of the file references within an assembly or a drawing, and allows us to choose which components we want to reuse and which components we want to copy, avoiding duplication of components and keeping our database nice and tidy. You'll also see that we can choose where we want to put specific components, and when we're happy, we can then commit these changes and copy our design. From here, we can go and have a look at the design. We'll create a quick shortcut, and inside of Inventor, we can open up our new design, and we can see all of the new part numbers, and you'll see that all of the references have been maintained. We have design automation through our logic inside of Inventor. We can automate tedious tasks and build really cool product configurators, all based on the rules set by engineering, with no programming knowledge required. In this example, we have a configuration set up by a form. We can choose different sizes of components, as well as the color and the motor type. And as soon as we commit this, we'll get a little information box telling us that we've had to increase the thickness of one of our components to accommodate the new width. Once we do that, our model updates. And along with the model, we also get our drawing updated as well. So from here, we could move to pushing this to the cloud. With an additional subscription, we could push this to a product called Configurator 360. And we get a very similar experience to our desktop experience, but as you'll see, we're in a web browser at this stage. So again, this is an additional subscription, but we're now able to let our customers configure their own products based on the rules we set up in engineering. We can also allow our customers to download specific file formats. So here we're downloading a 2D PDF of our drawing, but you'll also see the ability to download step files and Revit files as well. So if you create components that go into buildings, you could create a Revit file inside a Configurator 360. Your customers can also request a quotation. Subscription to the collection also gives you access to Nastran Simulation inside of Inventor. So let's have a quick look at how Nastran looks inside of the Inventor interface. Here we've applied some constraints, and we're now putting in a pin connector between those two faces of this component, and we can then apply a moment load to the pin. Once our load is applied, we can run through our mesh and contact settings, and we can then run our simulation. As soon as the simulation is run, we can preview how those stresses are plotted across our model. Nastran Simulation inside of Inventor gives us 12 additional simulation types over and above what we had in the original Inventor simulation. We can do nonlinear analysis, frame analysis, thermal stress analysis, buckling, and fatigue analysis, all within our familiar Inventor environment. Another addition is model-based definition. The idea is that we can create 3D annotations on top of our models, and we can share this using the STEP 242 protocol with other design software vendors. We can apply dimensions directly to our 3D models, and we can even include tolerancing information on top of the models as well. Another great new addition is the tolerance analysis tool. Inventor now has a 1D tolerance stack-up tool that allows us to calculate the cumulative effects of geometric dimensions, and this sits directly inside of Inventor. In this example, you'll see that we've got some 3D annotations on top of our model, and we can run through and look at adjusting our tolerances to see how that affects the overall fit and function of our component. One of the good things about this tool is that you can do this analysis on top of models from other CAD vendors as well. So you could bring in STEP files or other CAD files into Inventor and run a tolerance analysis based on that geometry. 3ds Max, which allows us to do really good high quality renders as well as 3D animations. But that's not all. The collection even comes with integrated CAM. We can do 2.5 to 5 axis milling directly inside of Inventor. This component needs to be milled, so we're going to go through and look at some basic milling operations inside of Inventor CAM. First thing we want to do is we're going to set up a facing operation, and we're going to choose a tool from our tool library. These tool libraries are fully editable, and from here we're going to choose the geometry and then go and look at making minor edits, like for instance the step over. As soon as we've done that, we can look at some adaptive clearing, and again, choosing a tool, we can then go through, select the geometry that we'd like to choose, make any adjustments, and Inventor will go away and generate our toolpaths for us. Once we've finished our machining strategy, we can run through and do a simulation of the machining, and we can see how material is removed from the stock live on our screen in front of us. Once we've finished looking at our simulation, we could go through and make a design change. And as you'd expect, if we make any changes to our model inside of Inventor, we'll be able to bring those changes through into our machining environment. So here's our model. We update that. It's a simple case of regenerating the toolpaths, and everything's regenerated for us. And from there, we can go and run our post-processor, and then we can look at creating setup sheets for the machining operations we've just created. For sheet metal users, we have the new nesting utility. And this allows us to optimize our manufacturing of our sheet metal components. So in this example, we're going to go and create a nest directly from our 3D model in Inventor. All of the components come through, and they're automatically assigned to the correct material thicknesses. So once our nests are created, we can go and look at each of the individual nests. These are nested by material thickness. And in this instance, we might want to go and have a look at the pitch control arms and maybe see if we can increase the amount of them that we create in this nest. So as we do this, it's regenerated, and you'll notice that a second sheet is created. And we want to include the brackets on the right-hand side there on the original. So to do this, we can go and change the item separation from 8mm down to 5. You'll see that as soon as that's regenerated, that those brackets are now included on that one sheet. and our material efficiency has now gone up. From here, we could export this out directly to DXF and send it to a waterjet or laserjet cutter. But in this example, we're going to create a 3D solid, and using Inventor's CAM environment, we're going to set this up to be used with a laser cutter. So what we want to do is we want to go through and tell it that our operation type is cutting. And once we've done that, we can then start looking at our 2D profile, choose laser, and then just select all the contours that we want. And Inventor's CAM operation is going to go away and generate that toolpath for us. And just like you saw before, we can run through and do a simulation, and we can then output the code to our laser cutter. A really exciting set of tools inside of the Product Design and Manufacturing collection are the factory design utilities. So what you see in the background is the process analysis tool, and this allows us to place virtual workstations or processes that you'd have in a factory down in a layout, and from here we can look at how long it takes to move material between them, and we can start looking at operational efficiencies in a nice, simple to use layout tool. Once we've done that, we can look at the reporting to see how efficient our production lines are, and from here we can export this to a DWG file, and we can start using it for space planning inside of Autocad. What you'll notice is on the right hand side I have an asset browser, and I can place down assets in my 2D environment, which we will then convert to 3D inside of Inventor. So we've placed down a conveyor, and I can convert that to an asset. You'll see it places that 2D conveyor down inside of AutoCAD. Going back to the Inventor factory area, you'll see that the assets I've just placed are now in 3D inside of Inventor. So 2D AutoCAD users can work in 3D using the factory design utilities. Here, using the same asset browser, I'm going to place down a robot cell. You'll see that these components snap together almost like Lego as we place the robots on top of this table. We can then visualize this inside of Inventor using the point cloud as well as the Inventor model. But sometimes I might want to look at this in a bit more detail or in a different way, and we have a tool for that called Navisworks, which you're seeing on the screen here. It allows me to walk through the factory. I can include models from Inventor as well as Revit and any other CAD package that I've used to design my entire factory. But the beauty of this is that I can run clash analysis. I can create an analysis between the structure from the structural engineer and my factory layout, and I can see where I need to make changes to accommodate that design. But what about some disruptive technology? Let's have a quick look at Fusion 360, and in particular, Generative Design. So Generative Design allows us to look at a model and to set up geometry that we'd like to preserve, geometry that we'd like to avoid, or obstacle geometry, and we can then apply loads to our model. And what we then do is we tell the algorithm in the background what we'd like to optimize for, whether that's casting, milling, etc., and what materials we'd like to use. This is sent to the cloud and processed, and thousands of design iterations are created for us, things that a designer wouldn't think of. We can then filter this by strength or stiffness or material, and we can see the results and then look at them on our model. An awesome customer example from General Motors, who have consolidated 8 components down to 1 using generative design. They now have a component that's 40% lighter, 20% stronger, and easier to assemble in the factory. But generative design is not only about additive manufacturing. We now have outputs for 2 and 2.5 axis, meaning that we can waterjet or laserjet cut components, as well as do milling on 2.5 axis machines. It's a big step change and really exciting technology available through Fusion 360. So when you ask yourself, does a subscription to the collection give you access to simulation, 2D CAD, 3D CAD, or data management? It's not one of these things, but all of these things. It's not a bunch of individual tech, but a tightly integrated Inventor-centric workflow.